non-stratified squamous epithelium. And then the endocervix is lined by endocervical cells, the columnar-shaped cells. That's all you need to remember. Okay? So in the uterus, again, there are different kind of layers, parametrium, myometrium, and endometrium. So the myometrium is the muscle layer, the smooth muscle layer. Okay, so this is a cross-section of a uterus. You can see that the muscle layer is very thick. So the uterus is sort of like a pear-shaped upside down. And this is the myometrium area, this thickness is the muscle, okay? And then the surface area here is the endometrium. So this is the tissue section of the cells. They take a little piece of tissue and then they cut across it and stain it. And that's what you see, okay, in histology. So in histology, we could see the architecture of the myometrium cells here and the endometrium cells here. In cytology, we would not be able to see the myometrium because it's too deep. Usually what we see in cytology are the surface epithelium because they could scrape it and sample it. In order for us to be able to see so deep, it has to be something eroded down that we will see it. Or otherwise, they need to submit it to histology. They actually use the knife, a little bicep, to get a chunk of the tissue off. Okay, without just scraping it, we will not be able to see it. Okay, so the endometrium, that's the different kind of cells similar to columnar shape, but they call it pseudo-stratified columnar. What does pseudo-stratified mean?
No, fake stratified.
Yeah, thick layers, right? So it's not like a truly layering. It's one single layer. However, the cells sort of shift up and down, so they create the illusion of look like they're multiple layers. In fact, there's only one single layer. Okay, so that's the surface epithelium look like, and the glands undergo regular changes throughout menstrual cycle. This is probably one of the most important things that we need to keep in mind later on when in another lecture too is the glands in the uterus, in the endometrium, corresponding to the menstrual cycles, okay? So the glands could be very simple structure or it could be very tortuous and tubular structure. So on the next lecture, we're going to talk more about the proliferative phase and secretory phase and the menstrual cycle and ovary function, all of that. But just kind of keep in mind here, the endometrium, the cells we are called endometrial cells, okay, endometrial cells. The endometrial cells undergo regular changes throughout menstrual cycle, and because of that, the appearance will look slightly different, okay. So again, here is the endometrium surface and the myometrium, which we don't see in cytology. We only see this part. Okay, again, here's the surface epithelium. You can see that it's one single layer, but because the cells so compact and the nucleus sort of shift up and down, it creates the illusion that look like multiple layers. Okay, that's why they call pseudo-stratified. Here's the stroma and the glands. Okay, the glands is the round thing. The stroma is the connective tissue in between. Okay, so pap smear sample. We talked a little bit about pap smear sampling the other day. So here is cross-section view of the pap smear sampling. So this little device is called a speculum. It's like a duck beak shaped little device. They insert it into the vagina and they open it. So the doctor could visualize the cervix area. What they do is they insert a little brush, get into it, scraping around the ectocervix and the endocervix area, and then they remove it. Okay. There are several ways of doing a sample. You could directly take that brush out and smear it on a glass slice, fix it in alcohol, and send it to the lab. Okay, that's the old traditional way before. It's very easy. You just brush it, scrape it, smear it on the slide, put it in alcohol, send it to the lab. However, a lot of time over the last 20 years or so, they have noticed that a lot of the material, the cellular material that being sampled, gets stuck on the little brush. So the material that you sample do not necessarily all being transferred onto the glass slide. The brush, the material gets stuck on the brush, they kind of smear it on the thing, and they throw it away. What happened is 90% of the cellular material remain in the brush, only 10% being transferred onto the glass slides. What kind of a problem would arise if that occurs? What do you think? If I'm taking a sample and I'm only being transferred 10% of the material, 90% of those material do not get transferred onto the slide. Is that a good specimen?
No.
No,
Why not?
because you wouldn't get like a full view of what's happening.
Very good. Because all the cells or material or infection or disease or whatever that's on that brush, only 10% get transferred on it. 90% of those get stuck on the brush because they get dry and it's being thrown away. So later on, they devised a new way to process the specimen, which is a lot more effective and a lot more cellular material. So they get the brush, just like before, they sample it. Instead of smearing the brush onto the glass slide, they deposit the brush into this solution. And then they kind of twist the brush around to try to release all the cellular material into the solution. And then let the solution fix the cells here and send it to the laboratory. Now, if they're doing this, does that mean all 100% of the material are being transferred into the fluid? Probably not. But at least now, I would think that there are at least 80 or 90% of the cellular material being transferred into this solution, and only 10% get left on the brush and get thrown away. Okay, it's almost impossible to get 100% of the brush material because there's always something gets stuck. It's like when you're brushing your hair. You try to get all the hair out, but there's only a few strands always that left in the brush, right? You can never have a really completely clean brush, so to speak. So that's the idea. And after that, the cells, the alcohol solution here in the cells vial have a very important function to preserve the cells. That's what the major purpose is. Okay, they preserve the cells from the moment that it leaves the human body into the alcohol fixation and preserve the cells. Once the cells preserved, it retains its morphology. If the cells are not preserved like the old way, if they have do it like this, smeared on a glass slide, what happened was the cells on the glass slides get exposed to air, and it become dry, it become degenerated, it become flaky. Okay, so when we look at the microscope, when the cells, they become distorted. It's not the original shape and size anymore. Okay, so that's a lot of what we call artifact when they're doing the old way. Okay, so now I think mainly there may be less than 5% of the laboratory will still get the kind of what they call conventional smear. Nowadays we all get the liquid base. Okay, however, this is a very inexpensive, cost-effective way, very cheap. You just get a box of gasoline, you sample it, you smear it, fix it, that's it. You don't need any kind of fancy machine, you don't need any kind of special equipment to do it. In contrast, this, you need the whole set of solution fixative, you need a whole set of expensive machine, special slide to do it. But you have a better result. Okay. So 95% of the laboratory or hospital in the US or in the Western society are using liquid-based, what we call liquid-based prep, compared to conventional prep. However, a lot of the developing country in Asia, South America, or even Africa, they're still doing the conventional way because it's much easier and it's much cheaper. Okay? Okay, so there are several steps of specimen processing. After they deposit the cells material into the vial, it could be sitting there for up until a few days or up to 3 months, okay, without hurting the cells. They preserve the cell morphology. So it does not have to send to the lab immediately. It could wait, if you wanted to deliver once a week, it could wait for a week and you just collect all the specimen. Okay, let's sit there. So the step for specimen processing is first to sample the cervix and the T-zone. It's extremely important to cervix the T-zone here because a lot of the time the abnormal cells arise from there. Okay. So the first step, sample the cervix T-zone, rinse the brush in the thin prep vial, what we call the thin prep vial. Make sure all materials are deposited in fluids or almost all of the material deposit. Fix the specimen for at least 30 minutes if they need to rush the specimen for a certain reason, then fix it for 30 minutes. Send it to the lab to process and prepare the slide on the thin prep processing equipment. After that, you can stain slide and cover it. Okay. So, let's see. It's only 10 o'clock. Let me check with the lab real quick. If they have an opening, then I'm going to bring you into the lab and show you how to do this part. Okay? All right. Any question so far? Yes.
In the sort of like the cartoon of the endocervical canal,
Mm-hmm.
there it's like a line, but then there are like lines across.
Which one?
It was sort of back a bit. It was in the
This one?
no, before that.
Before that? Okay.
Before that.
Before this one?
Yeah, it was like a different cartoon. Oh yeah, that one.
Okay.
So what are the like why is it sort of like have lines?
This
going out
little
horizontal?
line?
Yeah.
Oh, well, it's just an illustration. Remember the basement membrane?
Yeah.
In the real tissue, let's look at this on a close up. Okay, in a real tissue, this very bottom layer, the surface epithelium layer and the submucosa layer are two different types of cells. Okay, so the basement layer here, the cells we call basal cells, or in other words, they could also call it reserve cells. These are the kind of cells that have a very primitive nature, okay? Meaning that the cells, when they develop, they could develop according to the anatomical location. They could develop into squamous epithelium, or if it's in the endocervix, the same type of cells, they could develop into endocervical cells, okay? So this is sort of the defense line for the epithelium. Whenever we call the cells cancer or cancerous changes, is the basement membrane has been broken. The virus, all this thing has already crossed this baseline and invaded into the submucosa area. So this basal area is extremely important, okay? It's like the first immature cell line. And from there, because of the hormonal affection, estrogen, the cells is going to slowly mature into squamous epithelium, or in the cervix, squamous into endocervical cells, okay? So the line here in the cartoon, just to show you that there is a basement membrane all along, okay? And if you can see it here or here, this is the basement membrane, okay?
Okay.
So that's why they just wanted to show you clearly there is a basement membrane here. And all the surface epithelium, they mature. So this is like a defense line. Once they've been broke through, the cancer cells pass through that, then it could spread to other parts of the body. Okay. Any more questions? No? Okay, good. Okay, so I will put this into the drive for you guys.